The lesson outcome for this video is I can graph radical functions. All right, so y equals a times the square root of x minus h plus k is our general form of a radical function with a square root. And we are going to talk about h and k. Okay? Remember that hk represents the starting point of our curve. Just like hk worked with vertex form of quadratic equations, hk is that initial point that you want to plot so that you can graph the remaining part of the curve. So, for example, if I have the equation y equals 2 times, times the square root of x minus 3 plus 5, I will always start by naming my starting point. All right, so let's focus on that. Right here, since this is a negative 3, remember that our starting point is going to have an x value of positive 3. And because this is positive 5, that will go straight down as our y value of our starting point. So if our starting point is 3, 5, it will show up on the graph at 1, 2, 3 on the x-axis, 1, 2, 3, 4, 5 on the y-axis. So 3, 5 right here. Now remember, this is not going to be a parabola. It's not going to open up like this. It's not going to open down like this, although we get h and k in a similar way as we did with parabolas. But it's going to instead be just half of a parabola on its side. Okay, so if you can picture a parabola opening sideways, but only taking half of that, that is what a square root function is going to look like. So we need to know another point somewhere around our starting point so we know if it curves up and right, or up and left, or down and left, or down and right. So, like typical, again, if we use a table, we can put 3, 5 in for our starting point, and then we need to choose some other values for x so we can find out where it is going. So we can start by choosing a point just to the right or just to the left of our starting point. I'm going to go ahead and choose 2 for starters, the 2 right here, and see if we get a y value. Now, you could use your calculator or you can do the computing here. If I put a 2 in, y equals 2 times the square root of 2 minus 3 and then plus 5, I will notice that the square root of 2 minus 3 is the square root of negative 1. Now if we have y equals 2 times the square root of negative 1 plus 5, we should know right away that there's going to be no real solution because we've got a negative in our square root. So, no solution there. There will be no point where x is 2. So we know the graph now is going to curve either up and right or down and right. It can't curve this way because 2 doesn't have a y value. So let's go ahead and choose another point, maybe to the right of the starting point, so maybe 4 for our x value. So let's put 4 in, and now we're going to get y equals 2 times the square root of 4 minus 3 plus 5. Again, I'm rewriting the entire function, and I put a 4 in for x. Now 4 minus 3 is 1, and so now we have the square root of 1 right there, which is okay, that's fine. Square root of 1 is 1, so this becomes 1. 2 times 1 is 2, plus 5 is 7. So now we know there's a point at 4, 7. Alright, sorry about that. So 4, 7 is right about here. And it's not going to be a straight line through these points. It's not going to be a parabola. But we do know that this point is the starting point, and it's going to curve up and through this point as a half of a sideways parabola. Notice if I had continued it the other direction, I would get a sideways parabola. Okay, so let's take a look at these 3 radical equations. First, I'd like you to write these down, number 1, 2, and 3, and then I would like you to list the starting point for each one. Okay, and again, that is HK. Then restart the video and see if you have those right, and we'll continue from there. Okay, so you should have got for your starting points -1, -2, because again it's the opposite of this and exactly this. The second one you should have -3 and +4, again the opposite of this and this exactly. And lastly you should have 3, 2. The opposite of -3 here is 3 and +2. So those are our starting points for each function. So, next step, let's go ahead and graph our starting point and think about how our curve might go. All right, go ahead and plot those points on each graph. We'll call this number 1, number 2, and number 3. Okay, so the first one is at -1, -2. So our starting point will be at -1, -2 right there. Our next one is at -3, 4. So -3, 4 would be right in here. And the third one is at 3, 2. And 3, 2 is right here. Again, we need to know how these are going to curve. That half of a sideways parabola is going to go up and right, down and right, up and left, down and left. Again, we're going to need to choose another point to help us make that determination. So, we already have our starting point of -1, -2 for the first example. So, go ahead and choose another value to put in for x. Perhaps we will choose, let's see, to the right of -1 is 0. So maybe we'll try 0. If I put 0 in here, and you can use your calculator or your brain, either one I'm fine with. Let's run through this. 0 plus 1 is 1. The square root of 1 is 1. That 1 then needs to be multiplied by -3, so -3 minus 2, and that is -5. So we do get a value, which means we can plot that 0, -5, so 0 on the x-axis and -5 on the y-axis will be right here. Now, what that means is that the curve is going to go in the direction of this point from this point. So it's going to go from the starting point and has to go through here, so it's going to curve down and right. That is how this curve will go, because it needs to go through that point we found at 0, -5. Now if we picked another value here, like a 1, we could also find another value. If it makes you more comfortable, you can do that. Again, this is kind of optional here at this point, but if we put a 1 in, well, 1 plus 1 is 2, and the square root of 2 is 1.414. If we multiply that by 3 and subtract 2, we're going to get -6.243 approximately. So just smaller than -6. Well, does that make sense with our graph? Well, let's take a look at 1 for the x value, -6. That seems just about right there. So it does just keep curving this way, half of a parabola on its side. Okay, so the next one, we already have the point -3, 4. So let's choose another value of x. We can choose one to the right, or we can choose one to the left. That's my favorite option. I mean, you could pick a point way over here, but I usually just go one left or right. So let's choose this point here, -2. All right, so when I put in a -2 for x, this one gets a little bit interesting because of this negative out here. If I put a -2 right here, -2 plus 3 is 1. Now we get negative in front of it, so that's -1. Well, if we have the square root of -1, we know that there is no y value, because it will give us an imaginary number. So we now know that our curve is not going to have a -2x value, so we're not going to be curving this way or this way. We're going to be curving up and left or down and left. All right, so let's pick a number then to the left. So how about -4? Let's pick -4. If I put a -4 in here, at first it seems a little strange, so -4 plus 3 gives us -1. And you might think, oh, that's not okay, a -1. but it is because it's a negative -1. Here, let me write this one out for you quick. So we have y equals, not negative, we have y equals 2 times the square root of negative x plus 3 plus 4. So that's the equation we're working with. And we're going to put a -4 in. So y equals 2 times the square root of negative -4 plus 3 plus 4. And if we simplify this a little bit more, y equals 2 times negative, and then -4 plus 3. This is what I was just talking about. That will give us -1. If I put a -1 in there, now we have y equals 2 times the square root of -1, which is +1, plus 4. So we now know we have a square root of a positive number, which we can do. The square root of 1 is 1. 2 times 1 is 2, plus 4 is 6. So our y value is 6 when our x value is -4. So now let's plot that point. Coming back to this graph here, we're going to plot -4, 6. -4, 6 will be approximately here. And now we know that our curve is going up and left to go through this point right here. There it is. Again, half of a parabola on its side, because if I continued it this way, it would be a parabola on its side. But this time it's just half. All right, I kind of got into our space over here, but why don't you go ahead and try that one, finish it up, and we'll check it in class the next time we meet.